Hey, welcome everyone. Thank you for joining us. I hope everyone can hear me and see my screen.
Yep.
Great. Right. Well, we won't delay getting started. We'll get underway as we have some more people come in. But I want to thank you all for being here. If we haven't met, my name is Amanda Henley. I am the host of this user group. Today we're here talking about CICS, so it should be a great session. If you haven't gone to the new site yet, virtualusergroups.com, that is where you're going to find future event registrations, all of the videos and past decks and transcripts, all the good stuff. So change your bookmarks, update them. We've launched virtual user groups pretty recently, so just take a moment to note that all of the upcoming information is going to be in that new spot. Simple agenda for today. We've done the hard part of my introduction. We've got a couple more things to cover, probably, if I had to guess, no more than 3 slides, and then we'll dive into our presentation today. So I do want to thank our partners before we get going. Our sponsors for the virtual CICS user group are Broadcom, IntelliMagic, and Data Kinetics. And without them, we couldn't be putting on these presentations or producing our newsletter. So give them a shout. And then I wanted to just bring your attention to a post-session survey that will pop up as you're leaving today's user group session. I'd really appreciate your feedback on it. It's 2 questions today. The first of which is going to be, what are your thoughts on a future AI presentation? Multiple choice, so you don't need to worry too much about a long answer for it. And then the second question is just what did you learn? Did you learn anything today? So if you would, do me a favor as you're leaving, take 2 seconds to answer those 2 questions for me. And as I said, pretty painless. So with that, I am going to introduce Todd, and I am clicking slides all over the place. And Todd, if you want to go ahead, I'm going to stop my share. You can take the screen from me as we get started. But Todd Havekost is a senior ZOS performance consultant with IntelliMagic. His primary area of interest over the last 40 years in IT has been ZOS systems performance. He spent 26 years at USAA in multiple roles, including a mainframe architect. At IntelliMagic, he's really there to help customers leverage and maximize the value that they're getting. And he's also part of a team or is leading the cause in making sure your dollars go further. So I know we all appreciate that kind of work. And my guess is this is a superfluous introduction because you've probably met Todd before at a conference and seen him speak. So Todd, really excited to have you. Thank you for joining us.
All right, thanks everybody for joining today. I'm going to turn off my video now, and so we'll be focusing on the slides and the content. All right, so if you're a CICS specialist, expect you're already familiar with the metrics that are available in the CICS statistics and CICS accounting records, SMF 110 subtype 2 and SMF 1 subtype 1 respectively. And I hope you're getting great value from those metrics to enhance the performance and availability of your CICS environment. So those records were the focus of my presentation to this user group last January. And so the focus of this session is on ways CICS analysis can be enhanced through insights that can be gained from other types of SMF metrics across the Z platform. Or said another way, the ability to integrate CICS data with other types of SMF data can significantly raise the value of your CICS performance analysis. And the reason this is the case is that even though the CICS teams probably wish otherwise, CICS does not exist on an island, right? It operates within the ZOS ecosystem, interacts extensively with other components. And so that means insights that come from many other types of SMF records can play important roles in assessing and maintaining the operational health and performance of CICS. And some of those sources include RMS 72.3 data, provides several workload manager metrics of interest, including the extent to which service goals are being achieved and factors that are inhibiting that. And then when we start considering the multitude of connections between CICS regions with DB2 and MQ subsystems, this is another area where data from other SMF data types that feeds integrated visual topology views can be very helpful. And then for work originating from CICS, DB2 and MQ accounting data both enable their activity to be analyzed at the level of the calling CICS transaction. And now that ZOS Connect is playing a rapidly growing role at many sites as a single entry point servicing API calls from off-platform applications, ZOS Connect SMF 123 data can also be leveraged to provide visibility into the CICS regions and transactions that are servicing those calls. So integrated visibility into SMF data benefits all teams in all directions. It helps CICS teams identify how they might be being impacted by what's going on elsewhere in the ZOS environment, as well as helps other teams that are needing to understand what's going on within CICS. So this is a list of some of the capabilities that many sites are pursuing these days to enhance their analysis and increase the value that they're obtaining from their SMF data. And number 2 here is our focus today, to moving away from the barriers that are inherent in complex siloed tooling that's unique to each discipline, and utilizing a common, intuitive, integrated interface that provides visibility into many types of SMF data across the ZOS platform. When all teams have access to the insights that are provided by the SMF data from other components, this promotes collaborative analysis and expedites cross-learning. All right, so our first integration example uses workload manager service class data from the RMS 72.3 records, and those capture the workload manager performance indices, which reflect the extent to which a service class is meeting its goal. I'm going to be using IntelliMagic Vision today to walk through these sample scenarios because interactively exploring actual data and real-life scenarios is much more interesting and informative than slide images. So again, I won't be focusing on product features, but instead on showing how views into multiple SMF data types enables big picture analysis that's not possible when limited only to the CICS SMF 110 data. And again, if you're not a current customer of IntelliMagic Vision, hopefully these scenarios will prompt ideas of ways that your teams can benefit from integrating access to multiple SMF data types to enhance your analysis using your tooling of choice. All right, so we're going to start from this view of workload manager performance indices. Again, it indicates the extent to which the service class is meeting its goal as defined in the workload manager policy. 1.0 means you're meeting the goal, less than 1 means you're exceeding the goal, and above 1, you're missing the goal. All right, so workload manager supports multiple goal types for service classes. CICS regions are often typically assigned to service classes with execution velocity goals. And then production transactions are often defined as service classes with percentile goals, and we see both types of service classes defined here. Most of the transactions in this environment execute in this service class that for most of the day is far exceeding its goal, but it's missing for some early evening hours. Jumping over to a percentile view, again for that service class, we can see here that the goal for the service class is 90% of the transactions less than 325 milliseconds. For most of the day, more than 90% of the transactions are completing within half of that goal, 162 milliseconds. But for a few intervals right around 7 p.m., the goal is not being met, as less than 90% of the transactions are completing within that 325 millisecond goal. All right, so at that point, we pretty much reached the limits of what we can learn from the RMF 72.3 data, which is at the service class level. So now let's move over into CICS transaction data from 110 subtype 1. We'll start from a view of response times for the top 20 transactions by volume. Now I'm going to add a filter here because we saw that the goal was 90% of the transactions less than 325 milliseconds. So I want to look at the transactions, only ones that have an average response time that are greater than that goal. So when we do that, we find out that there are 3 transactions captured here that frequently execute longer than that 325 millisecond goal. So let's keep those 3 in mind. We'll come back to that in a second. All right, so now let's view transaction rates over time. And we've still got that 325 average response time greater than 325 millisecond filter in place. And when we see here that we have one of those transactions that we saw earlier that typically run long, we see that there's a big spike in volume in that transaction at the time when the WLM goal is being missed. All right, so I'm going to take off the 325 millisecond goal now. So again, now we've got all the top 20 transactions by volume. And I'm going to zero in now on that 7 o'clock interval and take the 2 adjoining intervals as well. All right, so that's just those intervals. And now I think we're particularly interested in seeing the distribution of transactions. Of course, a pie chart is a great way to do that. So when we do that, we see one of those 3 long-running transactions here, DWS, constitutes more than 9% of the transaction mix during those 3 time intervals. So combining WLM data with CICS transaction data enables us to identify that the cause of missing that WLM goal around 7 o'clock is the significant shift in the transaction mix at that time. It's tough to make a 90% goal when the volume of a transaction that consistently runs longer than that goal represents almost 10% of your total volume. So this is a dashboard that just captures the highlights of the journey we took in this example. WLM data said we were missing the performance index, that only 84% of the transactions were meeting the goal at that time interval. When we went over into the CICS transaction data, we found 3 transactions that typically run longer than the goal. and there was a big spike in volume of one of those, and the volume of that transaction made up almost 10% of the total. So that's one scenario where having access to multiple SMF data enhances CICS analysis, enables the CICS and WLM teams to collaborate to quickly identify the cause of missing a service class goal. All right. Another key success factor in managing a CICS environment is having a good handle on the multitude of connections between CICS regions and DB2 data sharing groups and members and MQ queue managers. Identifying these connections relies on data fields from the DB2 and the MQ accounting records, and this is also an area that can be greatly aided by views that help visualize these connections. At the recent GSE UK conference, IBM's Martin Packer drew attention to the importance of this subject in his session entitled "So You Don't Think You're an Architect." And the premise of his session was showing many ways you can gain architectural insights from multiple types of SMF data. He presented many examples at the system and middleware levels and highlighted the value of being able to identify how the components interface with one another. And then as seen in the red box here on his slide on the right, he particularly emphasized how the complexity increases when you move down the stack from ZOS to the subsystems, which often dramatically increases the number of involved components. And that multiplies the number of connections, right, among CICS regions, DB2 members, MQ queue managers. And so this increases the value that can be gained from capabilities to visualize the complexity of these relationships for sites small and large. All right, so let's examine some ways now that we can leverage views that integrate data from multiple SMF data types to visualize these connections. So here we're looking at relationships between CICS and connected DB2 and MQ subsystems. So kind of orienting to this view, the CICS functionality that issues SQL calls to DB2 and or MQ commands to queue managers appear in the center of the view. And then the MQ queue managers appear across the top, the DB2 members along the bottom grouped into their DB2 data sharing group. Now, since there are hundreds of CICS regions at many sites, this top level view begins at the level of customer defined CICS groups that are typically business application based. All right, so our next step then could be to expand a CICS group to identify the regions that are components of that group. So in this example, this group includes 5 regions. And we identify connections with 4 MQ queue managers along the top, 4 DB2 members along the bottom that belong to a single data sharing group. All right, looking at another group now, and one that has a few more regions. This group has, I think, about 30 regions, and despite the fact that the regions were grouped together kind of from a business application perspective, we see they have differing DB2 and MQ configuration profiles. Regions like this one have connections only to an MQ queue manager. Regions like this one have connections to one of the 4 members of that DB2 data sharing group. And then other regions have connections to both subsystems. All right, look at one more group here. And for groups that have too many regions to even have space to view all the region names, so they're just represented by dots here, we still can see from this view that the regions in this group have connections to a single data sharing group, and they have connections, most of them have connections to 4 apparently parallel queue managers. And then if we wanted to kind of look at the exceptions, then we could explore those and identify which regions aren't really part of that overall standard configuration. And then topology views like this can be leveraged to create DB2 centric or MQ centric views. For example, here with the highlighted blue lines are indicating the CICS group that interact with that particular DB2 data sharing group. And then for this queue manager, we can identify the groups that are connected to that. And we can limit the view now to just those CICS groups. And then there's numerous ways we could proceed from here. One way would be to expand the groups into regions and see the regions that are connected to that particular queue manager. And when we do that, we observe a naming convention. Almost all the CICS regions end with 5 that connect to that particular queue manager that's got a 5 in its name, and they connect to a DB2 member that has a 5 in its name as well. So we can see the value of a good naming convention here. Can also be value in viewing the relationships of CICS and the other subsystems in the context of their hardware CICS and ZOS system relationships. Let's look at this particular group and look at the regions in that group. And so this enables us, for example, to validate the high availability design for a given CICS group. The 4 CICS regions that belong to that group are distributed across 4 CICS and 4 ZOS systems. So this configuration is likely to deliver on a high availability design objective that only around 25% of available capacity is ever lost, no matter what component fails anywhere throughout the stack. Or we might be interested in viewing the topology, subsystem topology for a single ZOS system. One use case for this could be that we want to examine the scope of impact for downtime for maintenance for that particular system. So here we're limiting the view to that single system. And we can see then the components that would be potentially affected when that system is down. And from there too, we could go further then and look at the regions from any one of the groups that reside on that particular system. All right, continuing with that same system constraint in effect, we can also take the next step down the stack and look at specific transaction IDs. So initially, this initial view just has the transactions grouped by the first letter of their name. But again, we can expand any one of those groups, right, and see which specific transactions are executing, again, for that CICS group on that particular system. And for any given transaction, we can see what regions that the CICS regions that it's executing in. And again, and then we've still got that system constraint in effect. So if we want to broaden this out now and look at that transaction across all the systems, we can see we'll see that it runs on many regions in the group. And then, of course, again, the relationships between the DB2 members and the MQ queue managers. And then finally, if we want to, we can view the relationships with the CICS and some systems and see how work for that particular transaction is distributed across the CICS and systems as well. So to summarize, we looked at examples of how various types of subsystem topology views, again, these leverage multiple types of SMF data, can help visualize connections between CICS and its DB2 and MQ subsystems, the relationships with supporting CICS and ZOS systems, and then go down the stack and even look at transactions that are executing on those regions. All right, so now let's delve into the details of work that originates from CICS that executes within these connected subsystems. So we'll start with DB2, and we take advantage of the fact that DB2 accounting data captures the CICS transaction ID in its correlation name field. All right, so now we'll move to a view of accounting data. We're going to look at elapsed time profiles per commit. And I'm going to select a different day for the analysis here. All right, so we can view the CICS call attach work by correlation ID, and that enables both the CICS and the DB2 teams to view elapsed time profiles within DB2 that correspond to each CICS transaction ID. So this view includes a dozen frequently used timing buckets out of the 30 that are captured in the DB2 accounting records. So again, looking across the profiles for these various CICS transactions, we can see that the prominent timing elements include CPU within DB2. DB2 calls that class 2 CP time, that's in red. See component sync IO wait components. Again, that's when a IO has to be done synchronous with the unit of work because the get page can't be satisfied from a buffer pool. All right, so we can view the elapsed time profile for a given transaction within DB2 that's generated by a specific CICS transaction. Look at that over time. This is a area chart that takes a cumulative view of the major components. Again, those are the two major ones that we just talked about a minute ago. Or if we want to compare the components against one another, then we could choose to view this as a line chart as well. When we do that, we see that the CPU time is relatively consistent across the time interval, whereas there's a lot more variation in the sync IO wait time, particularly outside of prime time hours, when batch can often, the higher IO volumes associated with batch can also cause a lot of contention for DB2 buffers. So instead of being limited to a CICS only view where time spent within DB2 is a black box, integrated visibility across into DB2 accounting data enables the CICS team to easily understand what's driving DB2 elapsed time for any given transaction. Right, another step towards kind of this cross-discipline collaboration can be facilitated by a single view that combines data from both sources. So here across the top, we've got CICS 110 subtype 1 transaction data. Across the bottom, we've got DB2 101 accounting data. So for example, here in the second column, we've got the total CICS CPU as well as the CPU time within DB2. Since CICS also includes the DB2 CPU time in its reporting, we can we can tell here that the time within DB2, CPU time within DB2 represents approximately 10% of the total CPU for this particular transaction. Also, bringing together the different data types can also help us. For example, here we see a couple of CICS intervals where there's a lot longer response time, and we can see those time intervals correspond to times within DB2 where there was abort and rollback activity going on at that same time. All right, so now let's focus on DB2 CPU time for work that's coming in from CICS. And again, let's go ahead and just focus on work coming in from CICS. So the connection type will be CICS call attach. We'll set that filter. All right, so a common way to look at CPU going on within DB2 is to view it by plan, which is typically application-based, particularly for CICS work. So let's go ahead and view this CPU over time. And I'm going to kind of zero in on the top 5 to help take out some of the noise. When we do that, we see a bump for this top CPU consuming plan. We see a bump in the CPU in the evening on this particular day. So if we look at a day-by-day view across the entire week of data that I've got in this demo database, we can see that that bump in CPU for that plan is a regular occurrence, most days happening at 8 p.m. All right, so now let's go back and view activity for that plan by transaction ID. Again, we'll take advantage of the fact that that's captured in the DB2 accounting data in the correlation name field. And again, let's look at this over time. And again, extend it to the entire week. When we do that, we see that there's one particular transaction here in pink, GYEV, that is responsible for those evening CPU bumps. All right, well, let's now jump over into the CICS transaction data and see what we can learn about that particular transaction. And we're looking at CPU. And again, now I want to focus specifically on that transaction. So we'll just filter on that. Look at that across time. So the CICS CPU data shows that same jump in CPU, total CPU consumed by this transaction around that 8 o'clock time. So let's see whether that jump in CPU is driven primarily by CPU per tran, or if it's driven by the CICS transaction, the transaction rate for that transaction. So we'll pull both of those together. We can see that the tran rate is up a little bit, but it's still lower than it is during the day. But the CPU per tran is up around 6 times from what it's been running all day long. So the primary driver of that increase in CPU at 8 p.m. going forward is an increase in CPU per tran. All right, so seeing that spike in CICS CPU per tran and also in the DB2 class 2 CPU prompts us to want to look at the volume of SQL requests that are coming from that transaction. And again, we see a very similar time of day pattern. And so let's go ahead and bring the CICS CPU per tran into this same view. And when we do that, we see, yes, that there is a very direct correlation between the CPU per tran and the rate of SQL requests. So that's what's certainly driving the increase in CPU in that transaction at that particular time of the day. So again, just by as a recap here, here's some of the kind of views that we've looked at today on this journey as we look at the value for CICS analysis by having visibility into DB2 accounting data. So elapsed time profiles by CICS transaction ID. What were the components of DB2 time that were contributing to that profile? We saw CPU by plan and the spike at that 8 o'clock. When we looked into the correlation field, we saw that it was being generated by that particular transaction. And when we jumped over into the CICS data, we saw that indeed it was primarily being driven by a growth in SQL requests being issued per tran. So again, CICS analysis can be enhanced by having good visibility into DB2 data. All right, so now let's see what we can learn from CICS-driven work that executes in MQ. And again, we'll leverage the fact that MQ accounting data, just like DB2 accounting data did, MQ accounting data captures the CICS transaction ID for MQ commands that are issued by CICS transactions. All right, so we'll start off with analysis by connection type. And I'm going to look at a different time interval here. This particular day from 9 a.m. to 3 p.m. All right. So yeah, starting view, MQ CPU by connection type. And as we said, the MQ accounting data captures the CICS transaction ID. So now we can see this is the MQ CPU that's being generated by each CICS transaction and which commands are being issued to consume that command, right? Consume that CPU, open, close, and puts. Or if we want to look at command rate, for example. So that was a view by CICS transaction. We can also view the CICS activity by region. So when we do that here, we can see that these two sets of regions have very different profiles of MQ commands. This set of regions is doing a lot of gets. This set of regions is just doing a lot of puts. All right, so there's many metrics that are captured in the MQ accounting data that may be of interest for CICS-focused analysis. One example of that is CPU per get. Again, from a starting view by connection type, let's look at this by transaction ID. And again, we've got a lot of transactions involved here. So let's, in this case, let's look at the top 6 and let's do it by total CPU for the MQ gets. And when we do that, we can see that the CPU per get is a bit higher for these two CICS transactions than it is for the other ones that are consuming comparable amounts of CPU. So that's CPU per get. Maybe we would like to look at elapsed time instead per get. Again, let's look at it in a transaction view. Again, we'll go to the, in this case, the top 5, and let's look at it by the number of MQ gets that are issued. When we do that, we see that one particular transaction has a longer elapsed time. The raw values aren't high, but it has a elapsed time per get that's approximately twice the next set of ones. And then from here, if we're doing MQ focused analysis, then from there, we can analyze that by Q or by index or index type and so on. Okay, MQ accounting data also captures data about message lengths. And one way it does that is capturing the distribution of lengths that are grouped into the buckets, as shown here. So again, if we take a transaction-oriented view of this, we see that these 2 CICS transactions are primarily responsible for generating messages that are longer than 1,000 bytes, and pretty much all the rest of the CICS transactions, almost all their messages are less than 1,000 bytes. In addition to bucket distributions, the MQ accounting data also captures minimum and maximum message lengths. So again, let's do that here. Look at that, look at a transaction view, and we see there's some variability for some of the CICS transactions at least. The longest messages, this particular transaction is putting some messages that are longer than 100K. Now, persistent messages generate more MQ logging activity, so there is often interest in those. Now at this site, they're primarily coming, the persistent messages are primarily coming from channel initiators, but again, if we're again CICS focused here, so we can look at the CICS messages, and again, there's not many in total that are persistent, but of the ones that are, most of them are coming from those particular 2 transactions. MQ accounting data also captures time messages are spent on the queue, minimum, maximum, and total elapsed time from which an average can be calculated. So in this example here, the longer messages are batch or channel initiator, but again, we will look at CICS specifically. We can see that we've got 3 CICS transactions that are operating on messages that are on the queue a bit longer than those for the rest of the transactions. All right, one more CICS focused analysis for MQ is the maximum queue depth. And let's start again. Let's start by queue name. So the longest queues in the on queues are encountered by this delete queue, which typically has lots of messages on the queue. And at the transaction level, we can see that that is being accessed by lots of different transactions. Also, we may notice here we've got a spike in the number of messages on the queue for this particular queue. And so the MQ accounting data helps us see which CICS transaction encountered that long queue depth. So again, just by recap, here's examples of the kinds of views that we looked at today. CPU that's being generated within MQ by CICS transaction. Here was a region view. We saw different profiles of commands being issued. CPU per get, elapsed time per get, message distributions in buckets, maximum message lengths, persistent messages, average time on the queue and maximum queue depth by queue and for transactions. So again, CICS analysis can be enhanced when CICS team can gain insights from visibility into the metrics from the MQ accounting data. All right, ZOS Connect is becoming an increasingly popular front door to the mainframe for off-platform work that's issuing API calls to access business-critical mainframe data. And that access is often achieved by executing CICS transactions. The ZOS Connect SMF 123 data provides insights into the CICS regions and transactions that are servicing those calls. All right, so we'll start out. This is just a view of requests that are being issued by system, and let's look at it by API name. And so in this example, on this particular system, there's a peak of around 350 requests for that API name being issued per, and this happens to be 15-minute intervals. So that translates into slightly under 0.4 of a request per second. Now the ZOS Connect data will tell us that the requests are being serviced by CICS. There we go. And that ZOS Connect data also captures the system of record identifier and resource name. Let's add those to this view. And those then capture the CICS Apple ID, the CICS transaction, and the program name that's involved in servicing the requests for this particular API. All right, so now let's move over into the CICS 110 subtype 1 data. And let's look at that particular Apple ID. And let's focus in on that particular transaction that was identified in the ZOS Connect data. And we see a very similar transaction rate here, just slightly under 0.4 per second. So that suggests a one-to-one relationship between those API calls and executions of this transaction in this region. So while we're in the CICS transaction data, again, let's look at that Apple ID. Let's look at that transaction. And we can look at the CICS CPU per tran. And it indicates a really consistent 0.5 milliseconds of CPU per CICS tran. So that's the per API request, since those transactions map one-to-one to the API request. And that CPU time is divided pretty evenly between the QR and L8 TCBs. The ZOS Connect data, the SMF 123 records, capture 4 timestamps on the provider side of things when the request is coming in from off-platform and the mainframe resource like CICS is providing the response. Captures 4 timestamps. We can see them in the red boxes here, T1 to T4, and that enables the provider response time to be segmented into 3 components as identified in the purple box here in the upper right. Latency prior to reaching the system of record, which is CICS in our scenario, the time spent within the system of record, again CICS, and then pre-client latency, the time within ZOS Connect before the response is sent off platform to the client. All right, so now let's look at the response times that are in the ZOS Connect data. And when we do that, we see a spike at 4 p.m. in the time spent in the system of record, which again, we just saw it was CICS, it was Apple ID A01, CIC 70, and it was transaction CSMI. All right, so now let's jump back over into the CICS data and analyze that further. So again, the transactions running in that Apple ID. And now let's look at the response time for that transaction that's servicing those requests. And sure enough, we see a spike also in the response time data as captured in the CICS data at that 4 p.m. interval. And that spike is driven by dispatched but not using CPU in blue, indicating that the CICS region experienced delays in being dispatched by ZOS. All right, another metric that we can obtain from the CICS 110 subtype 1 data is the percentage of time work that was dispatched by CICS was actually executing on a CP. So let's zero in on that particular Apple ID that's servicing those API requests. And we do see a little drop in access to the physical CPU during that time interval. When we focus in specifically on the transaction that's servicing those API requests, we see it was particularly starved for CPU during that 4 p.m. interval. So again, just kind of recapping the analytical path we took there to do that response time analysis. The ZOS Connect data showed a spike in the time in the system of record at that 4 p.m. interval. And when we jumped over to the CICS data, it showed an increase in time of dispatch, but not using CPU. And when we viewed that data at the region level, particularly at the transaction level, we saw that indeed there was something else going on in the system that limited the access that CPU was getting to CPU. CICS was getting to CPU at that time. So again, access into the ZOS Connect data helps us understand how CICS is servicing those API requests, and then we can correlate data between the two disciplines as well. All right, so today we talked about use cases where multiple types of SMF data come into play. If you're interested in more information on how to leverage CICS transaction, CICS statistics SMF data, the 110 subtype 1 and subtype 2, to enhance your analysis, you're invited to view these videos from our IntelliMagic.com website. IntelliMagic offers monthly Z Academy webinars with educational content that's similar to what we covered today. And so here's a couple of upcoming webinars. And then if you'll be at Share in Orlando in March, we'd love to meet you, to stop by our booth or to attend one of our sessions. I mentioned earlier that I was using IntelliMagic Vision today as the tool to facilitate our exploration of CICS and other types of SMF data. Most of our customers choose to run IntelliMagic Vision from our private cloud. It means all they have to do is run our SMF data compression utility, FTP their data to us, and then we handle all the processing as well as software product upgrades. And then the customers have credentials and a URL to use in their browser to explore their SMF data across their platform in the same manner as you saw in this session. And they can also draw on skills from our consultant team to supplement their staff as needed. All right, Amanda, did we receive any questions during the hour?
We did. So let me go ahead and get you one of those. So first question, Dimitri is asking if there is a standard and manageable threshold percentage on event control for upper and lower queue depth definitions.
I don't know if that is a reference to queue depth. Today I talked about queue depth in the context of MQ queues, and I'm not sure if this is a reference to MQ or not. And if it's a reference to MQ, I would just say that depending on the application design, there might be queues, for example, that delete queue that we saw in the scenario where it was part of the design that there were going to be a lot of messages on that queue. So I guess if you've got, I guess, more detail on that question, you can send it, I guess, to Amanda afterwards, and I'll try to answer it better. The question is, the next question, these statistics real time, how's the data being streamed? So SMF and RMF data is historical, right? It captures the data that happened in a preceding interval. The data can be processed relatively near the time when that data is created, but it's not real time like a monitor like a Megamon or MainView, which actually gets data from control blocks. And then again, the data is transmitted to us in our private cloud. We process it and make it available to the customers through a web reporter. Next question is, long-running mirror setting create distortions in CSMI statistics. And again, several of you probably on this call are much deeper CICS people than I am, so I would probably have to defer to the audience in general. In the particular scenario, often that can be the case with CSMI. In the particular scenario where the data matched up so closely between the ZOS Connect data and the CICS data for that particular API name, I felt comfortable, talking about the CICS related statistics on that. Again, for the broader question, I would defer to other more skilled CICS people in the audience. So, all right. Well, thank you for that, Amanda. I'll turn it back to you for your closing comments.
Thank you. Todd, thank you for such a great presentation. I dropped my email address if anyone has any lingering questions that they want to ask. I will pass them on to Todd. So that was enhanced analysis through integrating CICS and other types of SMF data. We're going to move on to our articles and news portion of the meeting today. Not a ton of news, but there is, just in the past couple of weeks, a new posting over on IBM about what's new for CICS in 2024. So you can scan this QR code and access that article. I thought there were a few things on there that you might be interested in taking a look at. The next thing is the virtual user groups and Planet Mainframe and me are going to be, and IntelliMagic are going to be at Share in Orlando in a couple of months, beginning of March. So if you can, we'd love to see you at the conference, and come by and see us and say hey. There is over on the jobs board a opportunity for a senior CICS system programmer with ADP. Is based in the United States, but that is an opening posted in the past 2 weeks, I think. So you can check that one out. And then we're always looking for contributors. So in particular, I'm looking for writers for Planet Mainframe. And then if you've got an idea for a future session for the CICS user group, don't be shy, send it to me, and let's talk about having you present it, or let's talk about finding who the best presenter is for it. Ways to get involved, if you haven't yet, on Twitter, we have our Mainframe virtual user group that you can follow, Facebook, LinkedIn, and the videos are popped up on YouTube as well. But all of the resources you're looking for are going to be, again, at virtualusergroups.com. I want to thank our partners again, IntelliMagic, Broadcom, and Data Kinetics for their support of the program. And now to tell you a little bit about our next session, we're going to be meeting on March 12th, same time and same place, for CICS event processing and CICS policies. We've got Jenny He that's going to join us with the IBM Hursley Lab. So that's all for today. If there aren't any other questions or comments, we're going to look at that right at 12:30. So it was great talking to you today. Todd, thank you again for being our presenter, and we'll see you next time.